Hi, Assalamu alaikum. So we are in chapter 7, application of integration. Now we are going to learn about volume. At the end of this subtopic 7.2, you should be able to determine the volume of a solid revolution. In the previous video, you have learned how to find the area of a region. Now we expand our knowledge to find the volume. Solid form will be generated when its area is revolved or rotated 360 degrees about x or y axis. Now let's have a look at this area. Let's say if we have a rectangle, so this is the area of the rectangle, and then from the area itself, if we rotate the area of the rectangle, a cylinder will be formed. Let's have a look from the different angle. Second example, let's have a look. We now have an area of triangle. If we rotate the area of the triangle, we will get a cone. So now, from the area of triangle, a cone will be generated. And also, later, we can find the volume of the shape. Now we continue to case number 1a, volume of the solid generated when a curve or a function is revolved about x-axis. Now in this lesson, we are going to focus on a curve or only one function, and the rotation is about x-axis. So let's have a look at the volume formula. It looks almost the same as the formula of area that you learned before. But then if we can see here really careful, we have a pi and also a squared. Same as here, a pi and a squared. Both of these formula are the same. It just that depends on the question given you. Sometimes it gives you fx, sometimes it gives you a y. And if we are talking about x-axis, make sure that here must be dx. And we continue to example number 16. Calculate the volume of the solid generated when the area bounded by the curve y equals to x, x plus 2, and the x-axis. And the rotation is 360 degree full rotation about x-axis. So now we have only one function involved, and the rotation is full rotation about x-axis. Now let's sketch the graph first. Let's draw x-axis and y-axis. If you can see the function, it is a quadratic function, and from here we can find the x-intercept. The x-intercept when y is 0. When y is 0, so x plus 2. So we will get x equals to 0, x equals to negative 2. So now here is 0, here is negative 2. Since this is quadratic function and the coefficient of x squared is positive, now we know that the shape of the quadratic is smile shape. So let's draw a smile shape first. Okay, here is y-axis, here is x-axis. Now we want to find the focus area that is bounded by the curve and the x-axis. So there are two conditions of the boundaries. So the first one is the curve x plus 2 and the x-axis. So if you can see here, this is the area that we should focus on. Alright, now let's write the formula first. V equals to pi integral of a to b, and since our rotation is about x-axis, we use dx, and our subject will be y squared. Now let's find the value of a and b. A and B are the starting line and the ending line of your area. So it starts here, -2, and it stops here, 0. So we have pi -2 until 0. Now our y is x, bracket x plus 2. We are going to expand that first, becomes x squared plus 2x. Don't forget the bracket and the squared. And now we are going to expand it again. So x to the power of 4 plus 4x cubed plus 4x squared dx. Now we can integrate them. So pi x to the power of 5 over 5 plus 4x to the power of 4 over 4 plus 4x cubed over 3, 0, -2. Now we can substitute 0 and -2. So the first one is 0. Let's check this first. When we substitute 0 in here, here, and here, as we can see here, we will get 0. So now, since the substitution value 0, we will get 0, and minus with substitution the value of -2. Here is 1, 4 divided by 4. So x -2 to the power of 4 plus 4 over 3, -2 to the power of 3. Now, just find the value in your calculator. You will get your answer, which is pi 0 minus 16 over 15. And our final answer is 16 over 15 pi unit cube.